Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of S29709 component 61 of November 2020. And for this, I am using the work of an outstanding and one of my best student, Ms. Bisma Sami of class 2021, the Lyceum. Well, all instructions are very important, especially this last one. Give non-exact numerical answers correct to three significant figures or one decimal place for angles in degrees unless a different level of accuracy is specified in the question. Make sure you will follow all the instructions, especially this last one. Question number 1. It is known that on average 1 in 300 flowers of a certain kind are white. That means this is binomial and this is the P of binomial. A random sample of 200 and this is the n of binomial of this kind is selected. So this situation is of binomial. This population is of binomial with n 200 and p is 1 upon 300. See, n is greater than 50 and p is less than 0.1. So we will solve this question through Poisson distribution. Part A. Use an appropriate approximating distribution to find the probability that more than one flower in the sample is white. So we have to use Poisson distribution, and for that we need the mean of binomial because the lambda of Poisson is the mean of Poisson. So this is the mean of binomial. So first get NP. This is NP 2 upon 3. This is N and this is P. So X is approximately Poisson. More than 1 means 1 minus 0, 1. Because this one is exclusive, so this must be inclusive here. And you all know how to calculate probability in Poisson. 1 minus e power minus lambda, and this 1 is for this 0, and for this one we have 2 upon 3. This is the format. 1 minus e power minus lambda 1 plus lambda power 1 over 1 factorial. I hope you all know how to do this calculation. Justify the approximating distribution used in part A. So justification is this. N is greater than 50, P is less than 0.1. So these are two very important conditions, and you may mention this one. You have option. You can just mention these two, only these two, or you can include this as NP. So if N is greater than 50 and P is less than 0.1, we always use Poisson. We always use Poisson approximation to binomial distribution. You may mention all these three if you want. Otherwise, these two are enough. N is 50, P is less than 0.1. The probability that a randomly chosen flower of another kind is white is 0.02. A random sample of 150 of these flowers is selected. Use an appropriate approximating distribution to find the probability that total, this means sum of two Poisson variables, white flowers in the two sample is less than 4. So another sample, size is 150, P is 0.02, get NP. NP of this will be 3. And get the total of these two. This is X and this is Y. We need total. This is important. So you just need to add lambda 2 and lambda 1. Just get the sum of these two lambdas. So 2 upon 3 plus 3 makes 11 upon 3, which is here. Now find this probability less than 4. Less than 4 means 0, 1, 2 or 3, and use this format. So this one. So e power minus lambda. For 0 we have 1 here. For this one we have lambda power 1 over 1 factorial. 1 factorial means 1, so we are not mentioning this here. For 2 we have lambda power 2 over 2 factorial, and for this 3 we have lambda cube over 3 factorial. And make sure you give your answer up to 3 significant figures. If you want to take the screenshot of this solution, you can. Question number 2. In a survey, a random sample of 250 adults in F were asked to fill in a questionnaire about their travel. So this is the sample size. It was found that 102 adults in the sample, so 102 out of 250, travel by bus. Find an approximate 90% confidence interval for the proportion. Proportion means PS. Who travel by bus. So this is the formula of confidence interval for population proportion, sample proportion. So the formula of PS is frequency of requirement divided by total. So 102 upon 250 is the value of PS. So QS will be 1 minus this, which is this. And we have to form 90%. 90% means 1.645 here. So this number is 1.645 and this is minus 1.645. Because this is 90%, so this is 5%, and this is also 5%, so this total will be 95%. So if you will check this 95% area, you will get 1.645. Well, PS is here, this is PS, Z is here, this is PS, this is QS, and this is the sample size. And this is the confidence interval. Make sure you give your answer up to 3 significant figures. Just two things are important. Number one, this formula, and number two, this, the value of Z. Make sure you write the correct formula here and take out the correct value of Z from table or calculator. Part B. The survey included a question about the amount X dollars spent on travel per year. The results are summarized as follows. So we need to find unbiased estimates of the population mean and variance. So unbiased estimate for population mean is this. Sample mean, sigma x over n. So this is the mu cap, the sample mean. This is the formula for sigma cap square. You all know this formula. Ns upon ns minus 1 sigma x square over ns minus square of mean. And make sure you will use accurate value of mean. Well, sigma x square is here. This is ns. This value is fine, but this is better. Always use this fractional value here. This is the value, accurate value of sigma cap square, and this is the 3 significant value. And we will use this value in the later part. And here you should give your answer in this way, 202, 3 significant figures. And in later part, use this number or this number. A counselor wanted to select a random sample of houses in F. He planned to select the first house on each of the 143 streets in F. Explain why this would not provide a random sample. Because each house doesn't have an equal chance of being selected, because the sample is not random. If the sample was random, then each house would have an equal chance of being selected. So this is the reason. Question number 3. The masses in kgs of female and male animals of a certain species have the normal distributions. Find the probability that a randomly chosen female has a mass that is less than half the mass of a randomly chosen male. This is so simple. F is less than half m, and this half is the multiple of m. So you need to bring this half m on left side. So we need this probability. We have to find this. But before that, we need to find expectation and variance of this. For expectation, no problem. We copy the same sign. We copy the coefficient. And EF is here. This is EF. And this is EM. So this is the expectation mu. But this is important. Variance. In variance, since this half is multiple of m, so we have to square this half. And we have to change this minus by plus because variance can never be negative. This is very important. So this is the variance. And this is the exact value, accurate value of variance. We will use this value over here. So z less than this 0 minus mu over sigma square under root. This is the value of z, and this is the final answer up to 3 significant figures. I hope you all know how to manage this. For your understanding, I'm just sketching this here. So we need this number. Minus 0.441. We need this area. You all know how to find this area. And the answer is here. Question number 4. The diagram shows the probability density function f of x. This total area must be 1 because if this is the probability density function, express k in terms of a. Since this area is 1, so with the help of this area formula, we can easily get the relation of k in terms of a. This is k in terms of a. So the equation of this function will be y is equal to k, which is 1 upon a. Or you can say f of x. You usually use f of x or write f of x here. Y is also fine. Given that variance is 3, find a. Well, first we need mean. So mean will be a upon 2. Since this function is continuous, this function is uniform. It is uniformly distributed, so this should be mean. So you can get the value of mean from this sketch if you want. Otherwise, you can integrate this function like this. Here is the mean. When function is uniform, then you can easily get the value of mean or median. So here is the mean. You can either estimate from mean from the sketch or integrate this function. Now get ex square. So 0, a, lower and upper limits, and this is the function 1 upon a, so this will become x square upon a, and this is the answer of ex square. Now this is the formula of variance, so substitute ex square here, ex whole square here, and variance is 3. This number is 3. So you just need to equate this a square upon 12 with 3 and get the value of a. And your a must be positive because it is on right hand side. And according to this domain, a is positive. You can take the screenshot of this solution if you want. Next question. Question number 5. The number of absences per week by workers at a factory has the distribution, Poisson distribution. Find the standard deviation, which is so simple. The variance of Poisson is lambda, therefore its standard deviation must be under root lambda. So you just need to take under root lambda and give your answer up to 3 significant figures. Find the probability that the number of absences in a 2-week period is at least 2. This is so simple. 2-week period. This is for 1 week. So for 2 weeks, it should be 4.2. And we need at least 2. So at least 2 means 1 minus 0, 1. This 2 is inclusive here, so it must be exclusive here. You should not consider 2 here. 1 minus P01. So that's the answer up to 3 significant figures. Part C. Find the probability that the number of absences in a 3-week period is more than 4 and less than 8. So simple. First get value of lambda for 3 weeks with the help of this ratio method. So 5, 6, 7. Greater than 4 and less than 8. That means 5, 6 or 7. So get these probabilities. This will be the okay testing question. Following a change in working conditions, the management wish to test whether the mean number of absences has decreased. So H1 must has a lesser sign. They found that in a randomly chosen 3 week period, so lambda should be 6.3. There were exactly two absences. So this 2 means the test value. We have to test this at 10%. So the test value is 2, and because of this lesser sign, we have to perform the lower tail test. So we have to, and you all know test value is always inclusive. So get this probability x less than equal to 2. This is less than 10%, so this lies in critical region. So you have to reject H naught. You have to accept H1 that lambda has decreased. As 4.98% is less than 10%, so H naught rejected. Evidence that mean number of absences has decreased. You are accepting this fact. Since we concluded this H naught rejected, so type 1 error can be possible. State with a reason which of the errors, type 1 or type 2, might have been made in carrying out the test in part D. Since H naught was rejected, therefore type 1 error is possible or might have been made. This answer depends on this conclusion. When you reject H naught, then type 1 error might have been made or vice versa. The time in minutes for A's journey to work on Mondays has mean 38.4 and standard deviation 6.9. Find the probability that A's mean journey time for a random sample of 30. Since sample size is large, so X bar is approximately normal according to CLT. So this is mean and this is variance. We need this probability, 38 and 40. So you all know how to find this. Convert this in the form of z. 38 is here. This is mu, and the under root of this is here. And you all know how to find this. You have option. You can use a calculator. You can use table. You have choice. And that's the answer up to 3 significant figures. Well, A wishes to test whether his mean journey time is different on Tuesdays. Different means two-tail test, meaning same or not same. So this different word means two-tail test. He chooses a random sample of 30 Tuesdays and finds that his mean journey time for those 30 Tuesdays is 40.2. This is the test value. Assume that the standard deviation for his journey time on Tuesday is 6.9. So this is the standard deviation. State with a reason whether A should use a one-tail or two-tail test. He should use a two-tail test. Two-tail as looking for a change, different. Carry out the test at the 10%. This is so simple. We know H naught is this, mu. This is H naught is not equal to, mu is not equal to 38.4. This is the test value. Standard deviation is here. Sample size is here. And according to CLT, distribution is normal. This is here. Now check this test value with the critical value. So 10% means 5% each. So this is 1.64. This value does not lie in critical region. This value lies here. So you have to accept H naught. You have to reject this claim that mu has not changed. So accept H naught, no evidence that mean has changed. Explain whether it was necessary to use central. Yeah, exactly. We, as population distribution is unknown, because in this question, the distribution was unknown. We didn't know the name of the distributions. So for large sample size, we always use CLT. This is CLT. I hope this lecture will help you to understand how to solve the questions of S2. And an important advice for me and for everyone: we should be kind, and we should be humble. Allah Hafiz.